I'm the senior instructor here at CTE Solutions, and we'll be talking about web services. A better way to get a handle on how web services came to be is to look at how we evolved to them, going back maybe a couple of decades ago, when we were talking about inter-process communication. When processes were running together on a single system, process A and process B, if the two processes needed to exchange data with one another, there were a few techniques and mechanisms that existed back then. For example, we had pipes. Named pipes were one way for processes to communicate. If you remember back in the days of the DOS operating system, you may have executed a command such as this one, type readme.txt, pipe to more. Right, so using a pipe, the two processes could communicate. Another way to make this happen would have been shared memory. With shared memory, one process will write data in an unused part of memory, such as this one, and the other process can read from it. So it was a technique that was used, but led to a lot of problems. If the memory location was a poor one, you could overwrite another process, have instability, and those kinds of issues. Microsoft also had their component object model to make that work. Right? So if, for example, process B could be a library stored in a DLL, and process A could call functions from that DLL and make use of it. And that worked well for a while. Okay, there were other methods involved as well. Those are the ones that we're mentioning here. And eventually things extended on to the LAN. Once the local area network became prevalent, we still had the two processes, A and B, needing to exchange data with one another, but now they are residing on different computers. So if we have here the local area network, like so, and the two different systems here, with process A on the one machine, and now process B sitting on a separate machine. And the two processes still need to exchange data, right? But now it needs to be done over the network. Some ways that were done to create this, for example, COM was expanded into DCOM, the distributed component object model. So the library, the DLL, could sit on a remote computer, and the first computer could make calls to it and use its functions. Shared memory, of course, no longer works since we are on separate machines now. The pipes were extended for the network as well, and other methods came around. For example, remote procedure calls, where I can make a call remotely using specific port numbers over the internet, over the network, and sockets also came into play over the local network, which is the marriage of a TCP IP address and a port number. However, some issues eventually arose from having these separate systems on the LAN, especially if they are of different make and model or different architecture. For example, the first machine here could be a IBM PC, and this second machine over here could be an old-style mainframe. And because they have a different architecture, they may not process data the same way. Integers on this IBM PC could have been 16 bits in length, and the IBM mainframe, or in this case a mainframe in general, being 32-bit, could have been a 32-bit integer, being a RISC architecture. So we had to find a way to make sure the data was compatible between the two systems. Right? Even worse, if you're looking down at the actual bits being sent between the two machines, like so, one computer could have had the high order bit on the left and the low order bit on the right, and based on the architecture of the other system, the order could be reversed on the other end. So the data is being sent to the other machine, the same bit order here, like so. However, the other machine has the order reversed with the high on the right and the low on the left, so the data is not even read the same way. So we had to find a way to standardize data exchange. And what was used back then was a technology called XDR. It was an industry-defined standard called the external data representation. So for example, if application A needs to send two numbers, let's say 2 and 3, to process B, process B manipulates the numbers, for example, adds them up, and returns the answer back being 5 to process A. Before the data can be sent, for example, process A would translate the numbers 2 and 3 in XDR format, which process B would then unwrap and understand, process the numbers, come up with the solution 5, wrap that in XDR format, and send it back to the caller. And that worked well for a while. However, things evolved again, and the local area network was eventually replaced with what we now know today as the Internet Cloud. Once that happened, many of these existing technologies stopped working. Right? Distributed component object model no longer worked. Neither did sockets, neither did RPCs over here, and pipes. Reason for this is because once the internet became prevalent, people started putting up firewalls to protect their networks, and most of the port numbers used by these technologies were blocked. So therefore we had to find a different way to allow processes to communicate over the internet. So the industry took a look at this and asked themselves, well, what port numbers are available? Well, the ones that are used for web traffic. So let's use web technologies to transfer our data and make calls remotely from one system to another. Right? And HTTP being the protocol being used here over standard ports was chosen for this. And XDR, which is a binary standard, eventually evolved into XML, right? Which is the extensible markup language, which is text-based, self-describing, self-defining, right? And goes through pretty much anything. And the fine art of putting XML data inside a HTTP envelope is a protocol that we call SOAP, Simple Object Access Protocol. And this has opened up the possibility of an application calling another method over the internet, passing data in a standard format called XML, and being able to receive data back. Now you see this in play every day when you navigate from one website to another. For example, if you go to Facebook, if you go to any travel website like Travelocity or Expedia and so forth, you type in your destination in a box, submit your info, next thing you know you've got the weather in that country or the cheapest fares to go there by plane, the cheapest hotels. All that information is coming from different web services. To illustrate how that works, over here we have a web page that we are browsing to. We type in our destination, for example, London. Right? We click a button to submit that. The string London is sent over the internet to a variety of different web services. For example, here, one web service to get the weather. Like so. Another web service to get cheapest flight. Another one to get more information about it, hotels. Like so. All that information is returned. We have the weather forecast over here, the cheapest flights appearing here, hotels available. All that information is coming from different web services. The string London is being sent as XML to these various system calls. The data coming back is also sent as XML and then put back into the application here. Okay, and that is essentially how we got to web services today.